Good afternoon, everybody. Here we have a Polk T15 two-way bookshelf speaker. I'm getting like a buzzing, and I believe it to be the tweeter. I don't think it's my equipment. I think it's the tweeter is fried. I ordered a new tweeter. And also, if you're replacing a tweeter, you should also replace whatever capacitor or capacitors that are in series with it, because that capacitor may have gotten damaged when the tweeter was damaged, especially if the tweeter was electrically damaged and not just, mechanically blown apart. For example, if your voice coil shorts, now there's nothing in series with the capacitor to limit the current through that capacitor. So it's a possibility that the capacitor could have been damaged, and you certainly don't want to install a brand new tweeter, maybe an expensive one or a hard to get one, inside a speaker without replacing its capacitor. And if you want, you could replace the capacitor or capacitors in both left and right speakers if you're really concerned of a mismatch. This isn't my main system, but I do listen to it a lot. So maybe I'm going to do both capacitors. Now, the one in this speaker and the one in the left speaker. This is the right speaker here. So I ordered the tweeter. Once again, this is a Polk T15. It's a low price speaker. Somebody gave me these. I'm not going to get into why or how a tweeter gets damaged, but I ordered the tweeter, and I do know that this speaker has a 4 microfarad electrolytic capacitor, non-polarized or bipolar, in series with the tweeter. So I'm sure I have one of those lying around, so I'll replace that capacitor with a new one, probably the same electrolytic. In these speakers, I don't see the point in going film capacitors. Just, leave well enough alone. I'll take the cover off. Now, I'll show you. Incidentally, be careful with these. These are very brittle. So just, do a little bit at a time when you're pulling these off. So, here's what the speaker looks like. Very easy to get the tweeter out. 3 screws there. Not going to take the woofer out, but you have to take the terminal cup off in the back, which will let you have access to the capacitor. So we're going to do that next. Not going to take the tweeter out right now because, well, I'm going to probably continue this video another day, but let's see how much we can get done tonight. I don't have the tweeter right now. It's on order. And let's see what we can get done tonight on this. And just to take note of my polarity, I have the wire with the white tracer on it going to positive. See the white tracer here? Comes up and goes to positive. So these 4 screws will have to come out to get the capacitor. So, as I said before, this speaker has a 4 microfarad 50 volt capacitor. I went digging around. I have some 50 volt 4.7s. That'll lower the crossover frequency. Then I have some 2.2s. That's pretty close. If you use 2 of these in parallel, you'll have 4.4 microfarads, which is closer to the OEM 4 microfarad. Which I'm pretty sure is in there, and we're going to find out. So right now we're going to take this in the other room, and I have this meter. I actually went out and bought a capacitance meter before I realized that this meter also tests capacitors. So let's do some resistance measurements on this this little guy. We're going to measure all the drivers for resistance. And we're going to measure the capacitance and see what capacitance value is in there. Even if it measures correctly and measures around 4 microfarads, I'll probably still replace it anyway, because I don't want to damage a new tweeter. Because, you know, a static measurement like this isn't actual, you know, field activity. This isn't music going through it. It's just a meter. So I just want to be sure that this is going to be okay after the repair. So let's check it out. Now, it's always good to take this reading. It's a resistance reading. Doesn't matter if your probes are backwards. Doesn't matter, you're measuring resistance. So when you do this, normally you're measuring the woofer, but you don't know what the crossover looks like, and you don't know the condition of the crossover. But this is an 8 ohm speaker, so the woofer probably has around 5.33 ohm DC resistance. That's what we're going to measure. So let's put the meter on, and just for kicks, let's just get this reading. 3.9. That's a little low. That's a little low. I bet you if I measured the good speaker over there, it might read a little bit higher. But let's not do that, because I don't feel like disconnecting the other speaker right now. But we have this initial reading of 3.9. You know, that's a little bit low for an 8 ohm impedance speaker. So, which is what this is. So that tells me that there might be something in parallel with this woofer that's partially shorted, or the woofer itself is bad and giving me 3.9 ohms when it should give me like 6 ohms or 5.3 or so. I don't know if this is a correct reading for this speaker, but it's just a data point to have right now. So I just took out these 4 screws. I had a number 2 screwdriver and a number 1. I think this is the number 1, but the bigger one worked better because this one slipped out. You don't want your screwdriver slipping out of the screws. So now this can come off. I have to put the phone down. There could be a gasket on there. Oh, there we go. Okay. All right, there's the famous T15 crossover. Here's your 4 microfarad, 50 volt. And this is, oh, look at that, 0.3 millihenry. They even have it labeled. This is a coil probably going to the woofer to prevent high frequencies from getting to the woofer. You don't want high frequencies getting to the woofer. And the capacitor prevents low frequencies from getting to the tweeter. All right, the inside of the little Polk. Looking good. R15. Even though this is a T15 woofer, T15 speaker, it uses apparently an R15 woofer driver, mid-woofer. Okay, let's flip this around and see what's up front. Very simple crossover. I mean, look how, you know, capacitors are different sizes. This is a 4 mic 50 volt, and you saw how small. Let me shut the light off here. Look at these little guys. Those are 4.7 mic 50 volts. So, you know, different technology, different dielectrics. You could see the difference in size. So that big one's a 4 microfarad 50 volt non-polar. And these little guys are 4.7 microfarad non-polars. Now these are radials. That means the leads come out one side, see? And this is an axial. The leads come out either side. Okay? But what a difference in size. So this is the capacitor that may have been damaged. We don't know, and you won't always tell from looking at the outside. Sometimes you could see that it's leaking dielectric, or the pressure relief feature blew out. But this, from the outside, it looks fine. And this is just adhesive here. That's not dielectric. Okay, bye. Now, to properly measure things, everything has to be disconnected and isolated from each other. I can't really just test this capacitor now by itself. I have to disconnect the tweeter and the woofer to make sure that there's nothing else in the circuit that you're testing. You want an accurate reading. You know, like my terminal measurement here, that includes both drivers, the crossover, and everything, and the wiring and everything. So we're going to remove everything from this speaker, or at least test everything by itself. All right, I started removing the tweeter. It's 3 screws, and obviously the woofer is 4 screws. Now what I'm doing is removing the woofer so I could stick my hand in there and push out the tweeter, because it's a little hard to grip this guy, and I know he's probably got a gasket under him too. So we're gonna take this out now. If you're ever taking out a speaker, support the screwdriver with 2 hands, because if you slip, you can go right through the cone, and bye-bye speaker. So take your time and be careful. Okay, the woofer came out pretty easily. I just used the weight of it and it popped out. The terminals were towards the bottom. You want to make sure you put it in the way it came out. And the white wire with the red tracer is positive, and the plain white wire is negative. Very important. And you could see the little plus there and the little minus there. And the open part of the terminals is facing me. I like to put everything back the way it was. So now we can take this woofer out. Incidentally, some of these are very hard to get off. Even the little one was pretty hard. So you always have to support this little board that's held on with a little rivet there. Technically, I probably only need to remove one of these wires to make measurements, but we're just going to play it safe and remove both of them. This guy's giving me a little bit of a hard time to come off. I'd probably use the pliers here. We'll try to wedge it down, but I know I don't need to take that off to measure the resistance of this driver, so you only have to take really one of them off to get an accurate reading. Even though I said I was going to take them all off, since this one's giving me a hard time, we'll just leave it on for now. It's not going to affect the reading. Okay, so we're getting 3.8. Now, if you recall before, we were getting around 3.9 at the terminals. But, you know, there's some wire here and some connections. That'll easily add 1/10 of an ohm. So here we go. 4 ohm DC resistance. I'm going to quickly go on the internet to see what this woofer should be. Okay, so that resistance measurement is all right. This is actually rated to be a 6 to 8 ohm speaker. So measuring 4 ohms DC resistance on a speaker that's 6 to 8 ohm impedance rated is okay. If it was an 8 ohm speaker, I would expect more like 5.3 or 5.5 ohms or something like that, maybe 6. But this is a 6 to 8 ohm impedance speaker. So the 4 ohms I'm measuring, I went on the internet and many people got that same reading. So most likely this woofer is fine, and that's wonderful. On to the tweeter. Okay, I'm still going to leave that lead disconnected from the woofer. What's going on in here? Oh, okay. Oh, popped it out. Very nice. I'll charge my battery on the phone. So once again, the terminals are on the bottom. Interestingly enough, it's the white wire with the black tracer goes to positive, and the plain white wire goes to negative. Okay, so we want to make sure we put those back correctly. Incidentally, you can always check the physical condition of the speaker. Look in there, look at the spider, look at the cone. Make sure that nothing's separated or anything. If you press on the cone, it should move freely. And also use your nose. So I have the little tweeter out. It's hard to smell if it's burned out because this thing is like practically hermetically sealed. Look at this. Now, you can just change the cone there and the voice coil. You can buy the cone and the voice coil on these things. All right, let's cut to the chase and test this tweeter. I got the meter here. Just trying to get the leads here. I should use my clip leads to make things a lot easier. So we have a reading of 3. It's a 4 ohm impedance tweeter, I believe. So we're reading 3.2. Which is not bad. Not bad at all. Okay. Let's now test the capacitor. So we have to make sure that all these wires are behaving and separate. So we're going to test the capacitor. The capacitor goes between the positive terminal and the positive terminal of the tweeter and the positive terminal of the terminal cup. That's where the capacitor is connected. Alright, so we're going to go across the capacitor. You can go directly across it. I'm going between the wire that connects to the capacitor and the positive terminal, because that's what a capacitor is. So, okay, I'm not sure what that was. Alright, so I'll place the meter here so we all could see it. Alright, and then we're going to go on. If you remember before, it was the white lead with the black tracer, so oh, that's interesting. That's interesting. I'm going to double check the terminal cup just to make sure. Oh no, that's right. Okay. The capacitor actually goes to the, I was on the wrong terminal. The capacitor goes to the big terminal. But my phone is dying, so I need to plug it in. I have a cord right here, which is nice and handy. Okay. All right, let's get this reading. So I'm going to go to the large terminal here and see what we get. A beautiful 4.3 microfarads. All right, so ladies and gentlemen, from all of these electrical readings, I don't see anything wrong with this speaker. Now, that doesn't mean it doesn't have a buzz, because it does have a buzz. So what I'm going to do is just, not going to take everybody's time up with this, but I'm going to play the music that I heard the buzzing in, and I'm going to put my ear up against the tweeter and up against the woofer just to see which one is making the buzz. Now, a tweeter could also be physically damaged and not electrically damaged too. Or that capacitor could be damaged. So, I'm going to sleep on this. We're going to end the video. Thank you for watching. So, just some quick readings. We got around 4.2 and change on the capacitor. We got around 3.9 on the woofer, DC resistance. And what did we get on this? I think around the same, right? 3.9 ohms. We're going to check it again. I know it's on the video, but let's just check it quickly. Oh, running away, running away. Oh. This is, I got butterfingers tonight. Hold on. It's probably more painful for you to watch this than for me to do this. There we go. Alright, so we're in the low 3s on the tweeter. So, I just put the phone down a second so I can use 2 hands to measure. Are you listening to me, everybody? So I'm getting, on the tweeter, yeah, around 3.2 ohms. Around 3.2. So 3.2 ohms on the tweeter, DC resistance. 3.9 ohms on the woofer. And I got about 4.2 microfarads on the capacitor. Static reading, you know, the capacitor still could be bad even though it's reading that. Or there could be something physical that came apart inside the speaker, or maybe there's just something in my room that's vibrating near this speaker. And I'm blaming the speaker. I ordered a tweeter. It's always good to have a spare tweeter, because I'm always blowing these tweeters. So, there you have it, folks. The Polk T15 budget priced speaker. I gotta say, these things sound pretty good. And I'm in a bedroom. It's around, oh, I don't know how big this is. 15 by 15 maybe, roughly speaking. And they really do the job. I'm going to put this back together again. Thank you for visiting. Thank you for joining me on this Polk T15. Now, I understand Polk also has an R15, so that's why all these parts are labeled R15. I don't know if you guys noticed that, but so very interesting. Thank you for joining me, everybody. If I find anything out going forward on this speaker, I will put it in the comments and not leave everybody hanging. If I find nothing out and the noise just goes away, well, I'll put something in the comments in the near future. All right, we're just going to put her back together. Bye, everybody. Thanks for watching and happy listening.